Okay, this video is on practice set 5 question 3. So let's take a look at the following question. Now we're finding the maximum area of a circular sector with a fixed perimeter of 36 cm. Okay, so how do we go about doing this? First of all, I think it will help if you draw a diagram. Now, do recall what a sector looks like. So a sector is something like a portion that we take out of a circle, right? So if you recall your circular measure, right, a sector is like, you know, when you cut out a slice of a pizza from the circle. So if we look at the sector itself, then there are different parts, right? So we know that this portion here, this length here, that will be the radius of the circle, right? And over here on this part, that's usually our r theta, right? That's our arc length. Okay, and this part usually that's typically that's our r theta, which is our arc length. Okay, and here the angle that subtends the arc here, that will be theta. Okay, so I want to find the maximum area. So remember that when we look at the steps of maxima minima, first of all, we need to identify the function to differentiate in terms of one variable. So step 1, we always identify, we need to have the function. The function that we need to differentiate should be in terms of one variable. Okay, so this is often the first step for maxima minima question. So then after that, we look at what we need to differentiate. So they are looking at maximum area, right? Maximum area. So it makes sense that here we are either doing dA d theta or dA dr. Okay, so let's go with probably dA dr, right? Okay, so from here, if we need dA dr, right, we probably will need A in terms of r, right? A as a function of r. Okay, so which is what we are looking at. And what is A in terms of function of r? Now we know for sure that the area of a sector, the formula is equals to half r squared theta, right? So the issue here is that now there are two variables, that there's r and there's theta, right? So how probably if we are looking at, you know, having of A as a function of r, then the theta has to go away. So how do we you know, replace the theta in terms of r? This is where, if you look back at the question, you see that they provide you an information where the fixed parameter is 36. Okay, so 36, they'll tell you that now 36 here can also be the same as r plus r theta. Okay, which also say that 36 subtract 2r, quick math, divided by r, that will be your theta. Okay, so taking this theta and you substitute it here, you can obtain that now your area of sector is half of r squared. Now remember, we use 36 to formulate an equation for theta. Now let's substitute our theta inside, and then we have our A, our area of sector, totally in terms of r. Okay, so from here, let's go ahead and simplify this. Now cancel r. I eventually end up with a total of 18r minus r squared. Okay, so this is A in terms of r, and now remember we are finding the maximum area. So we need to do dA dr. Right, so step number 2, now we have the function in terms of one variable already. So now we differentiate. We differentiate our function. Right, so dA dr, if we were to differentiate 18r, that gives us 18. Differentiating r squared, that gives us 2r. Okay, now being the maximum area, that means we are looking at, you know, imagine we have an area and there's this particular r that gives us the maximum area, and at this point, remember, because it's a maximum point, the gradient will be 0. So then we are basically equating dA dr to be 0 in order for us to solve for that particular value of r. Okay, so 18 minus 2r, which is our dA dr, if we would equate this to 0, just simply work out the equation, and you know that your radius will be equals to 9. Okay, so it's telling us that this point here is 9, and of course you do need to conduct the right test to verify the nature of the stationary point. Now, because if it's stationary at this point, you only know if it can be maximum, it can be a minimum point, it can also be a stationary point of inflection. Right, so there are 3 possibilities. So how do we verify that it's the maximum? Right, so one very easy way, if you look at this function, it's quite relatively convenient to do the second derivative test because you can just differentiate a second time. So dA dr, so I mean d2a dr squared, if you do differentiate this again, you just get, differentiating 18, get 0, differentiating negative 2r, I just get negative 2. So you can see that this is less than 0, therefore r equals to 9, gives you the maximum area. Now simply, because the question requires us to find the maximum area, right? So just sub it in, area half r square multiplied by theta. Don't forget that theta is 36 minus 2r over r, and the final answer should be 81 cm squared. So this is your maximum area just by substituting it into the formula earlier. Okay, thank you.